You are designing a BigQuery data warehouse for a telecommunications provider's sales analytics. The business needs to model customers, products, and subscription data, all of which undergo monthly changes, while strictly maintaining comprehensive historical audit trails. The solution must remain high performance, cost-efficient, and optimized for BI visualization tools. Which approach aligns with these requirements? Option A. Employ a normalized schema with separate entity tables, utilizing snapshots to capture state changes. Option B. Use a normalized relational schema and store all historical state changes as individual files in cloud storage.
Option C. Implement a denormalized schema using nested and repeated fields, overwriting the main table and creating manual snapshots. Option D. Utilize a denormalized append-only schema with nested and repeated fields, relying on ingestion timestamps to manage and query versioned history.
Let's break down what this question is asking us to consider. We need to evaluate different schema design patterns and data management strategies specifically for a columnar data warehouse, like BigQuery. The key challenges involve handling slowly changing dimensions, where data evolves monthly, maintaining a complete and reliable historical audit trail, and ensuring that our queries remain fast and cost-efficient for business intelligence tools. We need to weigh the trade-offs between normalized versus denormalized structures. I believe the correct answer is option D. In BigQuery, denormalized schemas utilizing nested and repeated fields are the recommended design pattern because they minimize join operations, which are expensive and degrade performance. Furthermore, an append-only model is considered a best practice for tracking historical data. It avoids the costs and complexity associated with frequent DML update operations. By appending new records with an ingestion timestamp, you can easily query the current state using analytical functions like row number while maintaining a full audit history.
Option C is less optimal because managing manual snapshots introduces unnecessary overhead and complexity compared to an inherent append-only stream. Options A and B rely on normalized schemas, which lead to performance bottlenecks and higher processing costs when querying across joined tables in a data warehouse environment. As an exam tip, always remember that in analytical columnar databases like BigQuery, denormalization and append-only patterns with window functions are heavily favored over traditional normalized relational designs.